Welcome to tutorial number 250, GHS model creation. This tutorial focuses on geometry properties. So far we've covered the bulk of everything you need to know for creating geometry models in GHS. So I should say, geometry files. This is your GHS model. And remember, the steps are always: first you create your GHS model. That defines all the properties of your ship. And then we're going to get into analysis and how to actually use that model. So I want to finish off today with just a few more general properties that you need to know for geometry files. But first, a quick disclaimer. This presentation is for instruction purposes only. It is not to be used in engineering for construction. And I'm not a representative of GHS. These are all unofficial videos, unofficial training. Now, if you do want the official training, you can contact Creative Systems at the information on your screen. I highly recommend it. It's very informative. Okay, so let's get into some general geometry properties. The first one that's really handy is called comments. These are great as notes to other people. Very often in the marine industry, a geometry file becomes a living, evolving thing, and it actually gets passed from one firm to the next, and they modify it depending on updates to the ship. So it's very useful to actually be able to write comments to say what the changes were. And to do that, in the part maker, you use the comment command. So it's comment and then a number. The number specifies which line number. So you can use 20 different lines for comments. That's how many GHS allows. For people that are advanced users of GHS, they'll tell you that there are actually some ways around the 20 character limit, but I'm not going to go into that right now. Each line, you can use a maximum of 80 characters. Now that's 80 characters, not words. So you are fairly limited. You want to be brief in your comments. But it's still enough information to get in things like revision history. So for example here, we're saying comment, 5th line, and there's a date and who made the latest change. So at the very least, you know who to talk to find out what on earth changed. Things like that are what comments are very useful for. And when you open a geometry file, the comments will actually be displayed as the very first part of the output. Some other general things that are useful. Title. Title is very great to be able to write in the title of your geometry file. Usually that's going to be the name of the vessel. So for example here, you've got a title of an LNG deck barge. We also have units of measurement. So that's also very useful to specify the units of measurement for the barge. Or for whatever vessel you're typing in. That's a great thing to put at the beginning of your part maker files, so that all the other numbers that you type in as you're going down and defining them in part maker, that they're all in the units that you think they are in, because you've told GHS at the beginning that the units are either going to be feet or meters. That's also very useful because when this geometry file then gets opened, that converts GHS to use those units in the analysis, unless the analysis has an override put in, but we'll talk about that later. Then the last thing is water density. This is also very, very useful. So you can specify the density of your fresh water, or density of your salt water, or whatever else. If you happen to be designing a ship to go to some foreign off planet in the far distant future that has liquid mercury, if you wanted, you could specify that density as well. If you're actually designing a ship to go to a far off planet, I'd recommend software more advanced than GHS, but just saying GHS could do it. The next thing I'm going to talk about are critical points. Critical points are really, really useful. These are going to be used in the analysis, and you don't use them at the geometry definition stage. What you do though is you define them at the geometry definition stage, and you'll get to using them once you get to analysis. So what are they? They're used to track any position on the vessel relative to the water plane. And that's the key part, if you're concerned about where this is relative to the water plane. Useful thing, the way they get used, for example, is you're checking for down flooding, you're checking for weather type points, you're checking for water type points, or you can even assign them to specific tanks. So, for example, down flooding. We want to know if a certain critical point falls below the water plane. For example, this might be the vent on a tank. You know that once that vent falls below the water plane, that means it's underwater and water is actually flowing into your ship at that point. That's the kind of thing that critical points will be used to track. So the way you define it is the command is crit point, and then n tells you which critical point number you're going to be defining. You can have up to 250 critical points. Equals, then you have a description. That's going to be any description you want to give some sort of hint as to what this point is. And then you have your coordinates, your length, longitudinal, transverse, and vertical coordinates. So that defines the location of the point. Remember, it is just a point. And then we have a few options. So these different down flooding analyses are different types of points. That's where the options kick in. I'm not going to go into a whole lot of depth about what the different options do. You can look it up in your GHS reference manual. But so here's an example. Critical point number 5 is equal to, I'm telling you it's a hatch. And it's at 10 meters aft, 5.5 meters to starboard, and 11 meters above baseline. And I've specified an option here that it's a tight critical point. Meaning it's a weather tight point. And I will point out also that these critical points, the coordinates, they're relative to the ship. So as the ship pitches, rolls, heels, when you're looking at all that changing for stability analysis, the critical point moves with the ship. And that's why we have that's how it's tracking its position relative to the water plane. Okay, another useful thing is the margin line. This is something that you can define in hull items only. And the margin line is used for damage stability analysis. The margin line gives the distance from the deck edge to the water line. And that's going to be, excuse me, I misspoke. The margin line is, it's a margin for error, basically. In stability analysis, we don't want the deck edge to actually submerge underwater because you lose water plane area. So the margin line is the distance away from the deck edge. And when you start getting into a lot of the regulations regarding this, that separation distance actually gets smaller or larger at different sections along the hull, depending on what kind of a ship you have. So GHS allows several options for how to define that. And this is just defined as a specific distance, so it's not as coordinates or anything. So for example, you have it as the command margin and M1, M2, and M3. So if you were only to define M1, GHS assumes that it's a flat margin line. It's a straight distance. Now, that does not mean that GHS creates a flat line. The line will follow the curve of your deck edge, but it will always be the same distance below your deck edge. If you only define M1 and M2, it's a linear margin line. So it starts as that distance below your deck edge, one distance at the forward point, and proceeds to a larger or smaller distance at the aft point. And finally, if you have all of them in there, M1, M2, and M3 creates a parabolic margin line going from your forward point to your midships point to your aft point. So there's your margin line. that is defined within the hull parts, and it's very, very useful for damage stability analysis. Okay, homework number 251. What I would like you to do is open up the run file for the homework that you defined in homework 243. If you haven't really gotten that completed, don't worry. Homework 251 has a starting run file that you can work with. And I'd like you to add the following properties to that geometry file. First off, add some comments on the model creation. You add the date it was created, who the author was, the contact information. Then you're going to add the units of measurement and the water density, and define a few critical points. Those are actually listed in the drawing, so it can tell you what the points are. You have to define them in GHS. And then finally, I'd like you to put in a margin line. And that margin line is going to be 0.25 meters at the bow, 0.75 meters at the midships, and 0.25 meters at the stern. So that's a parabolic margin line. Okay, well, thank you very much for watching. I hope you have found this video useful and entertaining, and you can find the homework and several other videos like this on dmsonline.us.